We're going to be looking at perfect squares again and perfect cubes. Again, we've done this activity before. You actually drew the squares. If you had a square of 1, the length of its side would be 1. And then you try drawing a square with 2. You cannot have a square with an area of 2. You could have 2 rectangles, 1 by 2 or 2 by 1. Could not have a square with an area of 3 and have rational sides. But when you get to an area of 4, we now have rational sides of 2 by 2. And then quickly we saw the pattern. It's easier if you think of the side first. 3 by 3 is 9. 4 by 4 is 16. But we have to understand we can move back and forth between all of them. And you should continue this pattern up, okay, for a good ways. So 5 squared 25, 36, 49, 64, 81, 100, 121, 144, 169, 196. Then we get to 15. Then we get to 15, which is 225. And 25 is another one you should know, which is 625. So this list of perfect squares is going to be very important because we're going to be looking at estimating the square root. We want to understand if you have the area of the square and you're looking to get to the side of the square, that's called the square root. And if you have the side of the square and you want the area, that's this one down here, that's where you would be squaring it. Those are inverse operations. We could do the same thing here with perfect cubes. We got out our cubes. Okay, a cube has length, width, and height. Length, width, and height of 1 gives you 1 cube. If we go to a length, width, and height of 2, 2 times 2 is 4, times 2 is 8. It would have a volume of 8 cubes. Again, when we're dealing with squares, we're dealing with area. When we're dealing with perfect cubes, you're dealing with volume. So that would have a volume of 8 cubes to make it 2 by 2 by 2 tall. Next one we would look at would be having a side of 3. So 3 by 3 is 9 times 3 tall, 27 cubes would fill that up. If we had a side of 4, 64 cubes would fill that up. Okay, so we should continue this pattern on for a little ways as well on both sides. Okay, we're going to be using those numbers to estimate the roots, whether it be square roots, when you see that sign, square root. In other words, how big is the side of the square when they give you the area, going from area to side, or cubed root, okay, how big is the side of the cube when they give you the volume. So like the square root of 64 equals 8, the cubed root of 64 equals 4. 8 times 8 is 64. So if you had an area of 64, the side of the square would be 8. If you had a volume, or 64 cubes, so you'd have cubes, that would be 4 by 4 by 4. 4 times 4 is 16, times 4 is 64. Okay? So we want to have an understanding, first of all, of what we're talking about when we talk about squaring a number, or the square root, when we talk about cubing a number, or the cube root. Okay, that we're talking about going from area to side or side to area, and in cubes we're talking about going from volume to the side of the cube or the side of the cube to the volume. Okay, so they want us to estimate, again we're working through our book here, this is page 82, they want us to estimate the square root of 8. Now, 8's not a perfect square. You could make a rectangle 2 by 4, but it's not a perfect square. So to estimate what the side would be, in other words, you'd have to cut down. If you went 3 by 3, you'd have an area of 9. So what you have to do is you have to cut off some of each of those sides so that the area left in here would be 8. So all of these pieces you cut has to add up to 1 square. Okay, that's what we're looking at doing. How does that work on the number line? Well, you know that 4 by 4 Okay. I'm sorry, 2 by 2 has an area of 4, and 3 by 3 has an area of 9. So where does this fall in between those perfect squares? And we see this area is much closer to 9, so its estimate would come in there. Okay, a lot closer to 3. We're just going to ask you to estimate right now to the nearest whole number. So this is going to be rounded to 3. You could probably even put this in as like 2.8. Okay, but we're not asking you to be that specific in your estimate. So this would round to 3. So here's that process all laid out. Again, if you're looking for the square root of 83, the first thing you have to think about is what numbers does this fall in between? So 83 falls into between the two perfect squares, and that's where it's helpful when you have those charts handy to see those perfect squares that it falls in between. Okay, and so which one then is it closer to? It's a lot closer to 81. So we know those two perfect squares. That's what you're thinking here. This falls in between them. That's what this inequality says, that this 83 is bigger than 81, and less than 100. It's in between those two. And then which one is it closer to? It's closer to the 9. So they go through the whole process to, again, show you that that square root is going to be somewhere in between the 9 and the 10. They're just recording it. It's important that you can read that and understand thinking that it's recording that goes with that chart. So our estimate here would be 9. So let's say we want to do this perfect cube. Let's walk through this process then. First thing we have to know, and that would we probably get by looking at the chart, or if we could figure it out in our heads, but those are the two perfect cubes that's in between. Okay, 216 and 343. So thinking about that on a number line, where in between those two is this? So you've got to decide where on that number line that would fall. So again, you're thinking of it this way. It's in between 216 and 243. The rest of it is going to go through to get you from those to knowing that the cubed root will be in between 6 and 7. And then which one is it closer to? I think you can see it's closer to this, so it's going to be closer to 7. So that's what this part does. It shows you that 216 is 6 cubed, or to the third power. Those are inverse operations. The cubed root of 6 cubed is 6. Or you could write it this way, as they showed you over here. The cubed root of 216 comes out 6. They're showing you why. And then they're showing you that it falls in between those two, and our estimate here would be 7. So go ahead, there's some to try on your own. Give them a try. The answers will be up in a second when you come back. So pause this video and get those answers. Okay, you better have them because here they come now. 5, 4, 3, 2, 1. Okay, there we go. Again, looking at A, square root of 35, close to 36. Square root of 36 is 6, so 6 is the answer. 179, or 170, again, we're thinking that's close to the square root of 169, so 13 is our answer. That's closest to the square root of 49, so 7 is our answer. This is closest to the cubed root of 64, 4 is our answer. This is closest to the cubed root of 27, so 3 is our answer. This is closest to the cubed root of 125, so 5 is our answer. Again, we look at what those are closest to, what they're in between, but what they're closest to, and that's where we're getting our estimate from. Okay? So using an estimate like that isn't always the best. Again, it can be important at different times, and here's a situation where it's not. Okay? If we want to fence in a 2-meter area, okay, using that a process, we're going to get a fence somewhere between 4 and 8 meters. Okay, that's way too much of a variance. Here's where we're going to go to our calculator. So we're going to grab our calculator, and different calculators will have your square root differently. Sometimes you have to type the number and then push the square root key. Okay, it's always good to practice with that. Just take a square root that you know and make sure it's giving you the right answer. So we want to do the square root of 2. So square root of 2. And you see what that gives us as an answer here when we type it in. So using the calculator, we can get an answer as accurate as we want. So if we truncate it down to 1.4, you could then take 1.4 and multiply it by 4. This is what the example is showing you. Or you could be more accurate by moving it over to 1.41. So again, the answer is showing you're going to take that 2 then and multiply by 1.4, and that'll give you a much better estimate. Remember, no matter where you drop this off, even if you use all of these decimals that the calculator gives you, this is an estimate. Okay? That's a pretty accurate estimate, but it is still an estimate. The square root of 2 is irrational. That decimal keeps going forever, and it never repeats a pattern. So we want to understand the difference between a rational number and an irrational number where it continues to repeat or continues to go on as a decimal without repeating a pattern. So this would be a rational approximation when you do it to come up with, what do we have here, 2.8. Or if you went to 4.1, you could get another one, 2.84. So those are rational approximations of how much fence you need. Much more accurate than going out somewhere between 4 and 8 if you're just estimating it in your head. Okay. Golden ratio here, they talk about it. We've seen that in a clip before when we watched Donald Duck in Mathematics Land. They talked about the golden ratio. They're showing you what the golden ratio is, and they're asking us to estimate the value. Again, they go through this whole process to show you the perfect squares that 5 is in between. So estimating it, it's between 4 and 9. So your answer is going to come out between 2 and 3. Looking at the chart, that should make pretty easy sense to you, this whole section that they're writing down. So which is it closer to? It's closer to 4. So our estimate for 5, the square root of 5 would be 2. So you have 1 plus 2 over 2, and that's an approximation. 3 over 2, so 1.5 would be your approximation for the golden ratio. Okay, some guided practice for you to do. Again, follow what we just did in those examples. If you need to go back and look at them, go back and look at them. Make sure you do them first. We're going to put the answers up in just a minute, and we'll go over a couple of them too. All right, your video should be paused. You should be working on it. If you're looking at me before you're ready for the answers, too soon. Go back and get the work done. Here come the answers. 5, 4, 3, 2. Okay, there we go. We have all our answers on there. Again, we're looking at estimating which of those perfect squares or perfect cubes is it closest to, and that's where we have our numbers in the first one. Number 7, you use a calculator depending on how many decimal places you look at, depends on how accurate your estimate here is. Remember, no matter how many decimal places you go, it's still an estimate. Okay? You are estimating that because the square root of 60 is irrational. This is called a rational approximation. Because now we've written a rational number, it's not exactly equal, so it's an approximation. Okay? Number 8, we have 62.5 swings. And our essential question is, how can you estimate them? And that's what we went over. Put that in your own words, and we'll see you in class.